Okay. Hi, everyone. My name's Josh Stella. We've been having technical issues all morning. I hope you can hear me and see me now. Can somebody put in the chat? Okay, loud and clear. Thank you, Gurpreet.
You can see me too. Well, that's probably less lucky for you.
But
good. I am Josh Stella. I'm the CEO/CTO and co-founder of Fugue. We are a cloud security company
focused purely on cloud infrastructure security, infrastructure as code security. We were the pioneers in that back in the 2016 era, and 10 years or so of my life focused on cloud security. And so I think I've learned a few things that I want to share with you, and hopefully it is helpful. In the last really 2.5 years, Fugue completely re-architected our system, basing it on Lambdas. So in the past, we've been around. I left AWS to found Fugue about 7 years ago. By the way, when I was at AWS, I was a principal solutions architect for the Department of Defense and other national security kinds of environments, and NASA and folks like that. So just a few years ago, we re-architected on Lambda. We were on, EC2 and the earlier services, but we were doing a major shift in how our product worked to a SaaS, and we built it all in Lambda. And we have a few containers, and of course we have some other service types aside from just functions. But going through that experience was really interesting as an architect. My background is a programmer and architect, software architect. I'm not a security analyst, but I've lived in a lot of really security sensitive worlds. So I've been architecting systems, hopefully in a secure way, for a long time. So far, pretty well. So I was very interested to see how going serverless really changed how we had to think about the security of the system. And the good news is there's much less attack surface, much less, drastically less, because you're not worrying about operating systems that's managed by the cloud provider. And unless they've really done a poor job, and they usually do a very, very good job, there's no way to break out into the operating system from a function, so you don't have to worry about that stuff. But in another place, it gets a little more complex, and that's because your architecture is kind of externalized. Things that would have been bits of code talking to each other inside of one machine now become networked distributed functions. And so the attack surface gets smaller in the kinds of things you have to concern yourself with, and larger in the number of things you have to concern yourself with. Because if you do serverless really well, you're going to have a lot of these things. Okay. All right. Let's see if I can figure out how to share my screen on this guy. Share options. It's only seen 2 of my screens. Let's do that. Okay, I hope you're seeing a deck. Can somebody tell me in chat if you are seeing a deck? I'm not seeing any indication. Is that a no? Thaddeus, you seeing a deck? No, black screen. Okay, well, that didn't work. Let's try this another way. Thank you for that feedback. Let's try it over here. That screen it seemed to see. All right. yeah, it's not a black themed deck. Now it looks like you're getting a deck. Okay. Yes. Seeing a black screen. Okay. I think it's a deck now because I can see this little icon up here. It looks like it. I'm not used to this Excel events thing. Okay, cool. So what we're going to talk about today is blowing up serverless security. How the way I like to think about security is to think like a hacker. That's really all that matters, right? Things like compliance standards and so on are great and necessary, but are means to ends, and the ends are stopping hackers of one form or another, whether it's inside threat, external hacker, state actor, whatever. Good luck stopping state actors, by the way. But yeah, so I like to think like a hacker. And so the way I approach these topics, and I hope you enjoy this, is to look at it from that perspective. And how, as a hacker, am I going to blow up a serverless environment and breach it and get to the data, right? Usually as a hacker, we're trying to get to data. Alternately, might be crypto mining in your account, but usually it's get to data, at least somewhat. And that's primarily going to be through IAM configuration, identity and access management configuration. Okay, hence blowing up serverless security with IAM and how to avoid it. All right, we're gonna set the table. I'm doing that now. And thanks everyone for your patience while I had those technical challenges getting in here. But we've got a long session, so we should have plenty of time for covering everything that we need to and everything that you want to. Another thing I'll say is go ahead and interrupt me in the chat. I love it when people when these sessions are interactive. They're just much better. So if there's stuff you want me to cover that I'm not drilling into, or you have questions, or you want to challenge an assertion, whatever, just hit me up in the chat and I'll try to notice it quickly. So right now what we're doing is setting the stage, and then I'm going to do some deep dive. And what I mean by deep dive here is I'm going to be mostly whiteboarding and pointing at diagrams and resources through a web browser like the AWS console and so on, and just walking through a number of different ways you need to be concerned with your security. And then we'll make some recommendations. And it says Q&As at the end. The Q&A is all the time, okay? So anytime, just shout out. All right. So rethinking security in a serverless world. First of all, let me say, as I alluded to earlier, I think as security architects, as people who are engineering secure systems, the serverless world is awesome compared to what we were used to. But you have to think about it differently. And many of the misconfigurations that create vulnerabilities, they do often involve IAM. There are exceptions to that, but a lot of them involve IAM, and I'm going to explain why shortly. But a lot of these kinds of misconfigurations are not seen as problems in compliance standards. And so in Fugue, we support probably more than anyone, all the CIS standards and NIST and HIPAA and GDPR and NIST 853, ISO 27K. That stuff is all really important, but it hasn't really kept up with the times in terms of, well, at least most vendors' interpretations of, and most teams' interpretations and auditors' interpretations of those aren't really probably going to catch all the stuff you can get wrong in these serverless environments. And the reason is simply that they were really initiated thinking about data centers and servers and so on. In part because of that, most security teams don't recognize these things as vulnerabilities. They look fine, right? Very often security teams are reliant on those compliance standards to help them understand what's safe and what's unsafe. So because the compliance standards are behind, a lot of the security teams think they're in a better posture. My favorite, one of my favorite G2 reviews of our product, and I'm not going to be pitching our product today, but was that Fugue is gonna hurt your feelings. And what the guy meant, it was a positive review, but what he meant by that is we're going to find stuff that is dangerous that you thought was okay. And it's really important to have that cloud domain-specific knowledge, whether on your team or in a product like ours or something else, because these things go overlooked and the compliance standards aren't going to help you too much. Most of these are only apparent in the full context of an environment, right? You can't just look at the code in a Lambda. There are things you can do in code in Lambdas or other kinds of serverless functions that are dangerous and bad ideas. Most of the stuff that is dangerous and are bad ideas only becomes possible to reason about when you see that function in the context of the broader distributed architecture. So our director of security likes to say that in serverless, security is architectural, just fundamentally architectural. Okay. Excuse me. And because of all these things, easy to overlook during security audits. If you don't know you have problems, you're not going to find them. Your auditors aren't going to catch them, but hackers are aware of them and will exploit them. So this is the problem. And often they can exploit them without detection. So as you get into, excuse me, frog in my throat. As you get into the serverless and really distributed world, the traditional places where you look for issues, like at the network boundaries, largely become irrelevant because you're not typically traversing user visible network boundaries with these serverless distributed applications. You tend to be using the identity systems and policies as your network. And therefore, it can be really easy for hackers to do bad stuff that you will never even know happened. Okay, I want to talk a little bit about the dreaded shared responsibility model. If you're if you're a fan of Corey Quinn, you'll know that he has a much pithier and less safe for work description of this, in which he says it's basically all the hard stuff is on you. And okay, there's a lot of hard stuff that AWS and Microsoft and Google took on, but they do leave a lot to you. So if we look at this shared responsibility model, I'm going to assume folks are mostly familiar with it, but I'll spend a little time drilling into it. Down at the bottom is the lowest layer, right? This is like at the very bottom, you've got regions, availability zones, edge locations. This one is AWS focused. We're talking about like physical plant, right? You know, buildings. And as we go up, we get into the actual global infrastructure, like the networks that are run by the cloud service provider, the physical devices that the cloud services are run from, you know, the compute and storage and database and virtualized networking, and the higher order software kinds of, layers that they put on top of those, Lambda being one, for example. And that's where their responsibility ends in this version of the model. And then you go up into the blue stuff, that's all on you, it's on us, right? Client-side data encryption, operating system, network and firewall, platform application, identity and access management, configuration, and customer data, network traffic. All right, so when I design a system in the cloud, one of the principal things I'm trying to do is shove as much stuff to AWS or to Microsoft or Google in this shared responsibility model for security. I want to handle as little of it as possible. And this is a beautiful thing about serverless and things like managed databases, is a lot of that stuff you can shove onto the yellow side of this line in that software box. Okay, that software box are those kind of higher order services. So, and if you're using containers, you know, you can argue that containers are kind of serverless. I mean, they're more like little pseudo VMs, I suppose, you know. But actually, interestingly, on AWS, I believe all the native container services are actually not Linux containers, but micro VMs, which is much, much better from a security boundary perspective. No shared kernel memory space, things like that. But what you want to do is shove all this stuff onto them, right? If you can do that in a cost-effective manner. What we found for our application with Lambda is not only could we shove the vast majority of this stuff onto AWS in the shared security, in the shared responsibility model, but also our application got much less expensive to run in lots of ways, both in our AWS bill and in our maintenance costs, internally and so on. So So those things can go together. But you really want less of this on your plate, more of it on the cloud provider's plate. See if I get my mouse to the right screen. All right, so let's do some deep diving. I'm going to stop sharing for a minute due to my technical challenges earlier. My setup got a little munged, so give me just a second here. I'm going to share a whiteboard with you. Okay, so the first thing I want to do is really walk through a mental model of how to think about security in cloud in general, and in this case in serverless, it's like just fundamental to serverless security. Okay, so in clouds, and I'm going to use, I came from AWS. I'm primarily an AWS user, but everything I'm saying here is equally true on Google's cloud and Microsoft's cloud. Those are the three we cover in Fugue, so I'm familiar with, and I suspect similar on Ollie Cloud or OCI or what have you. But the important thing here is when you're thinking about security in the cloud, it can get very overwhelming. And so I think it's good to have a mental model that you can kind of come back to rationalize things, to get your head around things, because otherwise there's just so many details and so many devils living in them that it can really get out of hand. All right, so I'm going to use the AWS terms, as I said. So in the cloud, there are really, from a security and policy perspective, which is mostly what we're going to be talking about here, there are three kinds of principal objects, three kinds of like fundamental objects. One is principles. Okay, so does anyone know what a principle is in AWS? Well, I'll watch the chat and see, but I'll tell you on this one, a principal is something like a user. Okay, so you might have a human principal, which might be Josh, but it is also, and this is where in serverless, you're going to deal with this a lot. A principal can be a cloud resource. So for example, you can have a Lambda as a principal. I'll come back to this. So you've got principles, you have actions, and actions are things you can do through the cloud APIs. Yeah, principal, user or role. Exactly, Hitesh. Yes, it's the actor. If you're used to old like UML stuff, I shouldn't say old, people still use it, I guess. The actor is kind of what the principle is in AWS Cloud. The actions are the verb list. They're the API endpoints. So things like get object from S3 or execute on a Lambda, right? And then you have resources. Okay. Resources are things like EC2 instances, Lambdas, that's my favorite, RDS databases, the stuff you create that has unique identifiers. So instances of things in the cloud, your VPC networks, those are the resources. Okay, so out of the box, AWS has a default policy about which principles can talk to which actions and can talk to which resources. Does anyone know what the default policy is in AWS? I'm going to get a sip of water while I wait. Going once. Okay, it's deny everything. This is the correct architecture. This is very good design on their part. And what that means is if I am a principal, or let's say it's Josh, yeah, default deny all, exactly. No permissions, yes. Oh man, there is a real lag. So you guys were getting it. I just wasn't waiting long enough. Good job. That means I can't use any actions and I can't use any resources, right? None of that is provided me because it's by default deny everything. So this is where policy comes in the AWS cloud. Policy has a lot of locations, and this talk is primarily about IAM because a lot of this stuff is handled through IAM and is exploited through IAM in creative ways by hackers. But there's other layers of policy too that I'll speak to as well. So what you're doing with these policies is you are creating allowances. You're saying allow get object, for example. So you're poking a hole through that wall of denial. So Josh is now, if I have an IAM policy that says allow get object, S3 get object, now I can do that action, okay? And I never put an S3 bucket over here. Let's do that. And depending on how my policy is configured around resources, I may or may not be able to apply that action to this particular S3 bucket. We'll call it bar. Let's imagine in this scenario that I did allow for that. So as you're creating these IAM allowances, you can define which resources they apply to. This is something when I give a lot of these talks, yeah, here we've got David, resource bucket, SCPS, yes, KMS, etc. Yes, there's lots of places policy happens in the AWS stack. And many of these interrelate. And the way that they interrelate is the entire chain of policies that are relevant are kind of added up. And if anything in that stack denies, it's denied. So you can do patterns like, for example, having an S3 bucket with an S3 bucket policy on it that only allows requests from, maybe a CIDR block or a particular, VPC. And so you might have an actor that has access to get an object out of an S3 bucket, but the resource policy or the S3 bucket policy might then block that. And that's a valid and I think actually quite useful pattern. So, but the main thing when we're working with serverless is the number of principles is going to be huge if we have anything like a complex application. Okay, so in by principles, I really mean that I mentioned earlier. I put a lambda over on the left, and there's another lambda over here on the right. Why is that? Because when you create objects, resources in the AWS cloud, generally speaking, the right way to configure access for those things to other resources is by them acting as principals using the associated IAM policy, okay? So you end up resource to resource where the calling resource is the new principal. Remember, that's the actor, and the receiving resource is thought of as the resource from a policy perspective. So let me draw that too, because that's maybe a little confusing. So we'll get at it, but keep in mind the principal actions resource triumvirate there. So let's say we've got an application and we are starting with an API gateway. This is a very common architectural pattern for using Lambdas, for using serverless, is to have a gateway that is identifying the request type coming in within the API and delivering it to the correct Lambda based on which one it is. So what we're going to end up with are a number of Lambdas over here, and depending on how that request comes in, it'll route to the correct one. But then very typically what's happening in a serverless application is there are a whole lot more than those first entry point Lambdas. There's a whole chain of them that usually ultimately ends up hitting some data persistence layer of one form or another, either for a read or a write operation. So we might have over on the right here, you know, an RDS database or a DynamoDB table. Okay, and then we're going to have this big bunch of Lambdas in here, and maybe we have mixed in here some like, let's see if I can draw a whale. Some containers. I'm not going to try any more whales. That's pretty bad. I'm just going to mark Ks for, you know, Kubernetes. And we're chaining these together logically to perform operations, right? So in the pre-serverless days, you would kind of bundle your different operations together into a program, right? And the program would call functions within itself. So serverless is super cool because it externalizes those functions, right? It puts them on separate infrastructure. So for Fugue, for example, we manage millions of cloud resources for our customers doing security for them. We do billions of evaluations a day. We don't have to scale a server for our peak load because we have a highly variable load based on what our customers are doing. We can just let the scaling happen in the AWS Lambda service where things are going to get spun up for us as needed. So we're going to have a lot of these things. In fact, we can run a lot of them at once in Fugue. And so what you have to be concerned with then is what kind of permission you're giving as you work your way through this stack, ultimately to an RDS database. Oh, the whale is awesome. Thank you, Donald. If I could send you a t-shirt, I would. So you're going to be concerned with every one of these, right, is an allowance. Remember, deny everything, so no Lambda can talk to any other Lambda unless it's allowed to. Okay, so some of the advice I'm going to give, actually, I'm going to pull up a diagram. So here I am showing you Fugue, our product, but really just to show you how these things look. So, and I really should have pulled up, I'm giving a serverless talk. I should have pulled up a serverless application, shouldn't I have? Well, I didn't. So we're stuck with my bad choice. All right, what I wanted to show you is this. So this is an EC2 instance, which is a resource that is acting as a principal. Okay, it's acting as a principal because it is allowed to call other infrastructure, and it does that via this stuff right here, the IAM instance profile and the IAM role. Those that let's see what we. Oh yeah, here you go. So our product team are always adding really cool stuff. So so this is the demo app role. It's what's giving that thing the permissions it needs to go through. Now, normally when I teach this stuff, I recommend limiting the number of policies out there and roles out there because they can become really hard to manage. And I also normally recommend not putting specific named resources as limitations within an IAM policy. So in an IAM policy, you're going to have a few sections, you know, what you're allowing or denying, and you can have a resource section where you can specify on which resources you're allowing that. And normally I kind of discourage a lot of that use because in a lot of cloud environments, things are coming and going rapidly and changing names because the new one is going to have probably a different name. So those kinds of IAM policies can be really, really tricky to manage and can actually drive you to bad architectural choices. They can make you want to not replace stuff that should be, because now you got to go figure out everywhere it's touched. Well, that's the advice I normally give. I'm going to give you the opposite advice today for Lambda. I think in Lambdas, each of these Lambdas we've got, right, each of these guys should be limited, extremely limited in the IAM role that it is using as to what other resources it can talk to. So for example, it would be a really bad thing if this Lambda over here, if it did not need to talk to the database, if that had permission to talk to the database, that is pretty ugly. The more common, I don't see that mistake as commonly, because people tend to be aware that databases and the like are sensitive. What I do see more commonly is giving Lambdas the ability to execute other Lambdas and scoping that too broadly. That needs to be scoped. Yes, David says least privilege. Absolutely. And we're going to get to some of the implications of that, because if you're in a system like ours where we have hundreds and hundreds of Lambdas in very complex execution chains, this gets really tricky. But I'm going to share with you an approach that that we use. So this back to this Lambda over here. We also, if it doesn't need to talk to this to the whale, we'll talk to the whale, and we give it that. That is another form of security gap. And the execution commands, in that case, it wouldn't actually be an execute because that's a container, not, it would be some kind of network connection probably, or what have you. But what you don't want is for hackers to get a hold of the credentials associated with the role, right? So going back to our going back to here, this guy has, come on, this guy has this instance profile and a role. What that does is at runtime, it generates temporary credentials. So in EC2 and in containers, that's often distributed by the metadata service. In a Lambda, if somebody does manage to somehow execute some hostile code inside the Lambda, probably what I would do with it is try to get those credentials and spit them back out, return them, because those credentials can then be used, depending on how you've architected your policy, lots of places to do lots of things. So you really want those. Don't just think about, don't just think about, I keep losing my mouse, what is happening in your graph. Think about what could be done with any role you've granted here from somewhere else, because that's how they're going to do it typically. It's really painful to try to hack Lambda and do anything meaningful, because you can't really get purchase, right? So in the traditional world, you would get into something with an operating system, and you would kind of hang out there. You would get purchase there and then operate from there, because you had a bunch of tools. I do a talk on one breach, the one style of breach using IAM on EC2, where having shell and then access to the AWS command line is critical. Well, you don't have access to the AWS command unless you've got a really weird Lambda. I don't know if you could do that. Somebody tell me, could you bake the AWS CLI into a Lambda and have it function? I don't know the answer, but I doubt you're going to find it when you land there, right? If you're a hacker and you somehow get purchase in one of these things, like sloppily written application code, for example, you're really only going to be able to see the configuration of the Lambda and perhaps some cache data. That is something you should be aware of, and I almost forgot to bring up. Depending on how you're using these functions, you can have in-memory cache data left from earlier transactions. So do not think that the transaction boundary is a security boundary temporally on the same Lambda. So if you have a long-lived Lambda and it does, a bunch of different tasks for different people coming into the system, there is the potential there from one transaction to the next for there to be cache data left over from the earlier operation. And that's something a lot of folks don't necessarily think about in terms of security architecture with serverless. So what you want then is for each of these guys, and typically in these scenarios, the paths through these are really, pretty unique. Right, you're going to have some kind of operation up front that the API gateway is going to see. Maybe it's in our case, it might be like scan the cloud environment for security issues, and that hits a certain Lambda that kicks that process off. And then as we start scanning, we spawn, 300 Lambdas to do scans and policy analyses, and then it goes into a database, and then it returns some token. So there's this path through this distributed system. And each of those kinds of operations your system needs to perform probably have quite different paths with hopefully not a lot of shared long-lived resources. That's kind of an anti-pattern in serverless. AWS sort of optimistically named Lambda. And if you're familiar with what a Lambda is in programming, it's a function. Meaning that there are no side effects, right? And that's not quite true in Lambda. But what that means is a good way to think about these things are, as you're designing your system, both for application design and for security, idempotency and limitation of side effects. So in other words, you should be able to call the same Lambda function twice in a row with the same inputs and get the same out in most cases, until you get to the data persistence tier. Anyway, I've gotten a little off the trail. So how do you do this? Let's say, we've got hundreds of these things, and there are thousands of paths through. The short answer is a big part of your job when you're writing a true serverless application is your application should be generating the IAM roles it needs in an automated way. You should build that into your budget for programmer, okay? Because that is a part of the application design now. These IAM roles should all be generated every time you do a build of the system. They should be absolutely limited in scope. You should probably think about, and there's I don't really have a link to send you. I should have looked ahead. I'm sure there are projects on GitHub for doing this. We rolled our own, but you really want these IAM role associations and the policies that are attendant to them to be a natural thing that falls out of your CI/CD pipeline. If you're not doing that, I'm happier as a hacker, because you're probably doing two things. If you're not doing what I just described, or maybe someone has another option, that's the best one we could come up with, and it's worked really well for us. Because as we have grown the system and added functionality, we just add to the generation of IAM policies that we need, and it kind of grows naturally with the system. The upfront learning is probably the hardest part. I give a couple of talks on details of IAM that might be helpful there, that you can find on our YouTube channel. But if I'm not doing auto generation, I'm probably doing two things that are bad. One is I am probably not doing least permissive, least privilege. I'm probably being too broad. And as I said at the beginning, the worst I've seen that, or actually not the worst I've seen it, a common mistake is, well, any Lambda should be able to talk to any other Lambda. That's just Lambdas, right? No. Execution of Lambdas is not something you want most Lambdas to be able to do. Most Lambdas should not be able to execute most other Lambdas, and frankly, shouldn't be able to see them. And this is another aspect of cloud security that I like to really beat the drum on. 90% of hacking, at least, probably more like 95%, is discovery, is learning what is out there, okay? And denying hackers the ability to do discovery is a critical part of your security strategy when you're talking about IAM. So things like list permissions do not belong in your production environment. People think of list as harmless. It is not harmless. It is probably one of the most dangerous things to have sitting around in your running environment. Now, obviously, if it's Josh on the left or David on the left acting as a principal, I'm going to need some list permissions. I can't go and do something like this where I want to go interrogate the whole infrastructure and enumerate everything and diagram it. I need the list to do that, but I don't need this thing running in this to have the list permission. That is super dangerous. So trying to keep track on time. We got a few more minutes, I think. Well, any questions on anything I have shown you? And I know we've got a delay, so I'll wait a couple of minutes while I type in a URL here. Okay, not seeing any. I'll give it another sec. I'm going to show you a little bit about creating IAM policies. This is pretty central. I mean, as you get good at this, you're going to automate it, and you're not going to be clicking around an interface. But to learn about it, it is pretty helpful. Oops. Okay, so what I've done here is I've started a policy that is oriented toward doing things with the Lambda service and resources, okay? And what you're going to see in here are different categories. List, right? Yeah, like this guy, list functions. Don't put that out there. Don't do that. If I can list functions, I can probably infer what they do. And you've probably got some function out there in a distributed architecture that's like database connector, something like that. S3 read writer. I don't know. But if I'm a hacker, if I can list functions, it gives me a little bit of a map. I start to build a mental map. All right. So here you can see Lambda. One of the other nice things about Lambda is there are, believe it or not, so few of these in the service. If you compare this to something like EC2, where I think there are 400. Oh, these are the actions that I was talking about in the diagram, right? You have the principals, the actor, you have a list of actions, and then a list of resources. So these are the actions. And there's lots and lots and lots of them in AWS. But Lambda only has, I don't know, it looks like maybe like 60. Maybe not even that. 24, 25, 26. I was in the ballpark. Yeah, probably is about 60. Yeah. So learn these. This is a manageable list. So the older services, the bigger services like EC2, boy, is it a hill to climb to navigate through the 400 and change actions on that service. It is really challenging. Much less so with Lambda. Lambda is much easier to understand. And I think that maybe that's AWS learning with experience, how to not give us so many actions to try to manage. It could also just be a function that EC2 has been around forever, and AWS does a really good job of not deprecating actions and API endpoints, because man, that can really break systems, right? If you've already written something that relies on them. So learn these. Again, I would recommend, turn that off. You don't need to list in production. There's other ways to pass that data around through a secrets manager or something like this, even a database. Most of these reads, like get account settings, you don't need that. And the various write ones. So you want to be careful when you're creating your IAM policies. Really spend a lot of time there. Use ruthlessly that principle of least privilege, of least permissiveness. Careful with your allowances. Where did my deck go? Oh, it ended up over there somehow. I'm having a bad computer day. Oh yeah, here I've actually got some of these recommendations to put in front of you. So instead of just me calling them out, you can see them. Yeah, so least privilege, 1 IAM role per function. Be careful. Oh, we didn't even get into this. Cross-account IAM can be really nasty in terms of the unintended consequences in these environments. So be very careful with that. Yeah, use code reviews to identify vulnerabilities like event injection. In an earlier form of this, I had our head of engineering with me, and he actually shared some code on event injection. Actually, that's up on our YouTube channel. There's a couple of classes on serverless on our YouTube channel that actually have source code in them. Today I didn't do that. Yeah, delete lambdas you're no longer using. Delete everything you're no longer using in the cloud. Orphaned infrastructure is just very tasty to hackers. It's probably being ignored, and it's probably full of mistakes that you've made in the past. Yeah, minimize your dependencies and keep them up to date to avoid library vulnerabilities. So we partner with Sonatype, and there are other tools out there that will really help you understand that. I'm down to a minute here. Don't use the Lambda execution environment to store user data or events. This is what I was talking about, where you can't have cache data sitting around that or data in memory that lives across invocations, which might be different users. So don't do that stuff. Yeah, avoid executing shell scripts within Lambdas if possible, especially if handling user input. Definitely put them behind an API gateway and use the authentication mechanism in the API gateway, and protect the APIs with a WAF are our recommendations. And I'm just about out of time here, so yep, serverless security is deeply architectural, but you still need to write secure code. If you have code vulnerabilities, then IAM, well, that's how they're going to get to the IAM, I suppose. But yeah, I'm just going to pull, we're out of time, so I'm just going to pull another couple out of here. We don't recommend putting lambdas in VPCs. In some cloud architectures, VPCs are a security benefit. In lambdas, it actually opens an entire attack surface. so we don't recommend doing that unless you really need to. Yeah, I won't read these whole things out loud to you because we're running out of time. We're out of time. That's me. I've got a request for our YouTube channel link. I will send that.